This is the Study Spot Finder. We are Group 12. My name is Maria Inez.
I'm Perla del Castillo.
I'm Andrew Kwong.
I'm Darwin Mutaro. Study Spot Finder is a device that helps students find available study spots on campus using an online reservation system through a mobile application.
These are our system specifications. For the purposes of this demo, we will be demonstrating the highlighted specifications.
For this demo, we will be using the following terminology. The main field to observe will be status. When status is 1, it means the device is available and the color is green. When status is 2, the spot is momentarily reserved and awaiting confirmation. The color for this is yellow. Lastly, when status 3, the spot is reserved and the color is now red, which is the final state of the reservation.
Here, the user signs up for a new account. She types in her full name, her email address, which will be used to log in into the database, her phone number, and the university name that she is attending, and the associated university ID, and finally the password. And once she fills up all the fields and presses sign up, as you can see here in the Firebase database, after the user submits their initial account information, you can see here that the new user gets populated into the Firebase database. So here the user has created an account and now she is typing in her email address that's associated with the university, as well as her password as well, which has to be greater than 6 characters. And when she presses sign in, she gets automatically signed in into the home screen where it shows all the statuses of the device.
This is our current display. We have different devices listed, and right now we are only modifying the first one. The 0 is the empty key code field, and the smaller 1 is the status field. Moving over to the database, we can see the different values. Key code is used to verify the correct user for the hardware device. Outlet shows how many plugs are available at the study spot. Status is used to track whether or not a spot is available, reserved, or awaiting confirmation. And status received is used for hardware debugging. Valid is used for key code authentication. As you can see, the green LED represents that it is currently in status 1. Once the user presses the button on the mobile app, it immediately updates the Firebase status value to 2. The next time the hardware checks for updates, it receives the value as seen on status received, and it sends this information to the Arduino, which changes the LED status to yellow. While awaiting confirmation, the user must input a 4-digit code generated by the app. Here, the user puts in 1134, and the key code is sent with a push button. This is reflected in the database and authenticated, making the status 3. Once again, the mobile app and the LED reflect the status by turning red. For the first specification, the measured time for the device to receive the status update was 4.54 seconds, which is within the expected time. For the second specification, the LED was able to change according to the status in 4.71 seconds, which was in the specified time. The mobile application reflecting status updates was almost instantaneous, which met our specifications. For this project, we have created a successful prototype of our device, which houses all of the external components and communicates to the database through the Wi-Fi module.
We have also designed and ordered the first iteration of our PCB. We have successfully assembled and tested the circuit.
Some of our challenges include flashing the proper firmware onto the ESP Wi-Fi module. Another challenge was level shifting for proper serial communication between the Arduino and the ESP, which was resolved with a diode pull-up resistor circuit.
Another challenge were errors in the PCB schematic design, which resulted in mixed communication signals and missing traces.
Our final challenge was obtaining parts on time. since they had longer lead times than expected due to the global pandemic, COVID-19.
So our initial challenges for the front end was picking the right front end language that was applicable for the job. So we had a couple choices, iOS, Java, and we felt that both of these languages were clunky, and we decided to choose React Native, which was definitely a lighter development platform. And when initially coming to development with React Native, there was that small initial learning curve because it involved JavaScript, which we had a little bit of experience with. But it was a small learning curve, so we eventually got over it, and it was actually easier to implement when it comes to traditional web programming, such as HTML. And after going over that curve, we were able to implement some initial wireframes for the initial user experience and design for the project. And the biggest challenge to tackle that was learning how to convert those designs into code. And one of the initial code challenges was learning how to switch screens when it came for users to proceed to the next step. It actually took me a couple hours to figure that out, but we got over that really quickly. And learning how to connect with Firebase with React Native, because Firebase was initially hard to set up, but when we were able to set it up, we encountered some connection problems, also with authentication problems was one of our biggest issues. And when it came to user testing, coding on multiple devices, a lot of cellular devices have different screen sizes, so designs can look different from one screen to another. For successes on the front end side of things, we were able to create a authentication experience so that when users go onto the app and fill out their personal information, such as the school, university ID, and email address, we were able for them to create a login and log out functionality so that when users can log in, it gets personalized with their own information. And when it logs them out, their information gets saved onto the database. We were also able to configure a overall good design of the application when it comes to picking color schemes and a design that won't look awful when the user uses the application, because user design is somewhat critical when it comes to front-end development. And by doing so, we were able to present an enjoyable app experience by taking in considerable details with minute details such as scrolling when there's too much information presented on the screen, and error checking when user puts in a wrongly formatted email address or the wrong password, as well as checking if the security for the password, if it checks when the user tries to log in to see if they have the right credentials, and it won't allow them to do so.
The first challenge for the backend was that we were not familiar with Firebase at all. This was brand new to us, and we were not sure how we were going to communicate to it using JavaScript. Another challenge was figuring out how we were going to communicate back and forth with the hardware device. We needed it to be quick since this device had to work real time as the user makes the reservation. Now, for an ongoing challenge we're currently facing, we're trying to figure out the best way to do authentication with the key code. We were looking to see if we were going to do the comparison of the key code value entered through the device and the code generated in either the hardware side or the software side. As of right now, we're looking into doing this in the hardware side, but we're still trying to figure out the most efficient way to do this. Even though we were new to Firebase, we were able to successfully connect to the database in Firebase. We're able to communicate back and forth almost instantaneously. The user is able to receive information in less than a millisecond. For this, we're using the real-time database. The real-time response between software, hardware, and the database is the most important part of our project. This is what gives a great user experience to the students.
Overall, our project is on track by meeting our specifications as well as our desired timeframe. We hope to move on to a final PCB design and further development on the software, as well as integration and testing. Thank you for watching.